far as having all of the pages. Y'all taking pictures of the whole entire page. It was much easier for me to look and see what was there and what was missing. So thank you for that. I'll go ahead and get this started so Chad will be able to watch it when he gets back.
I'm throwing my phone too out of solidarity. You are a sock. My little cousin, she's so cute. She's obsessed with mushrooms right now, and she like loves to identify them. I can see her. Well, if she's studying, she'll know she's one of those. I'm like, every time I see one of them, they're so beautiful, but I want you to go back here. My friend, well, like, eat. You know, all
right. I need all the talking. Okay, so we're open to page 36. This went along with lesson 16, dealing with our properties. Okay, so the direction is to solve each equation, and then for each step, identify the property of equality that was used. Okay, so hopefully you wrote down the property. If you did not list them out, then we need to go through and kind of talk about them. So page 36. Everybody up in the 36?
I listed them out because I took a picture of the properties and I took each number and I would write the number.
Okay, all right. So one of the things that I need to start seeing is I need to start seeing work, okay? Because as I'm going through and grading these, if I don't see your work and I just see an answer, I don't know how to help you when you've made a mistake, okay? So one of the things that I need you to start doing is listing out your steps. I don't want to just see answers, okay? At some point, I'm going to start counting off. If you don't have answers, I'm going to give it back to you to redo, okay? So I need you to get into the habit of listing every step. This is to help you prepare for next year for geometry. In geometry right now, we're writing proofs, and we have to write every statement and every step of what we're doing and give every single reason why. So this will help prepare you for that, okay? So I need to start seeing your steps, just like we do when I do them on the board. That's what I need to see that you've done, okay? All right, so we did activities 3. We're going to go down the left-hand column and then the right-hand column. Remember, this is not time to correct them right now. It's time to mark what you missed and then go back and check them and fix them before our test, which we will talk about in a little bit, but that will go home on Thursday. Okay, so the first one, 6x plus 5 equals 23. You should have found that x equals 7. The first thing you had to do was subtract 5 from each side. Then you had to divide 6, and you ended up subtract 5. Huh? Yes.
That the
6x plus 5 equals 23.
Yeah.
I'm sorry, I jumped down to the second. I jumped down to the answer underneath it. Thank you. All right, sorry, I jumped down. I read the problem and I jumped down to the one below it. So the first one, x is 3. The one below that, x is 7. Okay, so on that one, you had to distribute first. We had to distribute first. Wait a minute.
Wait, which one are we on?
I need to just look at, instead of looking at this where it's got this listed out, I'm going to look at problems. Okay, so for the first one, we said 6x plus 5 is 23. We said that we solved that one and x is equal to 3. To solve that one, we had to subtract 5 and then divide by 3. Below it, it looks like we did this one together in class. We did use the distributive property. We ended up with 3x plus 6 equals 27. We had to subtract 6 from each side and then divide by 3. The one below that, we have 4x minus 1 equals 20. We had to distribute the 4. We ended up with 4x minus 4 equals 20. So we used the distributive property. Then we had to subtract 4 from each side. I'm sorry, add 4 to each side. And then divide by 4. And x was 7. Underneath that one, 2 times x plus 1 minus 5 equals 31. We had to distribute first. We had to combine like terms. Then we added 3 to each side, divided by 2, and found that x is equal to 17. Questions on the left-hand side?
Can you go over the third one? Yeah.
The third one is at the 4x minus, or 4 times x minus 1 equals 20. The first step was to distribute. So that we would end up with 4x minus 4 equals 20. Okay, that was our first step. Then you had to add 4 to each side. Because it's 4x minus 4, I have to add 4 to each side. So you should end up with 4x equals 24. Then divide by 4, and x equals negative 6.
Wait, what? Why is it negative?
Hold on a minute, because okay, so let's take a look at that one. I think my book is just, it's just my eyes. Y'all, it's so hard to see this little, that's the equal sign.
Is it positive?
It's a positive 6.
Okay.
It's just my vision, and the putting on the mask does not help, and so it's a positive 6. Sorry about that.
And it's very small writing in general.
I was gonna say, in the teacher's book, the size of the page, like I'm trying, the size that y'all's page is, my page is like that. So it's hard to see as it is, but then especially having eye issues and wearing plastic over your eyes doesn't help. Okay. Let me just repeat the answers for the left-hand side. I'm not going to tell you what the steps are. I'm just going to tell you the answer.
All right.
So left-hand side, the first one is 3. Underneath that is 7. So we have 3, then 7, then 6, and then 17. Right-hand side. See if I can do better on the right-hand side.
You got it.
We started out with 5x minus 7 equals 28. We had to add 7 to each side and then divide by 5. So x is equal to 7. The one underneath that, I have 7 times x plus 3 is 49. I have to distribute first, so you end up with 7x plus 21 equals 49. So that means I have to subtract 21 from each side. And then I have to divide both sides by 7. So you find that x is equal to 4. Underneath that one, 5 times x minus 2 equals 45. Distribute the 5, so you end up with 5x minus 10 equals 45. Add 10 to both sides, divide by 5, and you end up with x equals 11. And then the last one, 6x minus 5 plus 7 equals 55. Distribute the 6, so you end up with 6x minus 30 plus 7 equals 55. I've got to combine like terms. So I have 30 plus 7 is 30, I'm sorry, negative 30 plus 7. Okay, so when you add negative 30 plus 7, what do you get?
Wait, negative what?
So here,
Negative 30.
when we had to distribute, this 6 times 5 is a negative 30
Negative 30.
plus 7. Negative 30 plus 7. Opposite signs, find the difference. So you should have had negative 23. Then you have to add 23 to both sides. So that's what I'm saying. If you didn't list it out step by step, if you don't have your steps, you're not able to see what you missed and what you didn't miss. But you should find that x is equal to 13.
Yes. Oh, well, I got that. I think I did it right.
X is 13.
How did I get that? No, you probably right. On here and then headed on here, so it's all jumbled up.
Alrighty, so that was page 36. Let's move on to page 37, activities 2. Same thing here, 37, activities 2. I'm just going to go through and I'm going to tell you the answers. And then if there's any that we need to go through, we'll go through. We'll go down the left-hand column, middle, then right-hand column. right. Listen up, please. So for the first one, x is equal to 4. For the next one, 7x minus 5 equals 4x plus 7. X is equal to 4 also. 4 times x plus 1 equals x plus 19. X is equal to 5. Any questions on the left side? Middle column. 8x minus 9 equals 3x plus 26. X is equal to 7. 2x minus 8 equals negative 3x plus 27. X equals 7. 7 times x plus 2 equals 2x plus 29. X equals 3. Any questions in the middle column? Right-hand column. 3x plus 5 equals negative x plus 17. X equals 3. Underneath that, 9x minus 2 equals 2x plus 33. X equals 5. And then the last one, 3 times x plus 4 equals negative 4x minus 16. X equals negative 4. Any of those you would like me to work?
The last one.
Okay.
The last one. I got negative 7. I got negative 7.
Okay, let's take a look at this one. What is the first thing I need to do in this problem? Distribute. Okay, so we use multiplication to distribute the 3 to x plus 4. I told you I always draw my little arrows, so I make sure that I do everything correctly. So I have 3x plus 12 is equal to negative 4x minus 16. Okay? What am I going to need to do now? What side do I want my variables on? The left-hand side. So I'm going to go ahead and I'm going to add 4x to each side so I can get my variables on the left. What is 3x plus 4x? 7x. So now I have 7x plus 12 is equal to negative 16. What needs to move now?
12.
12. It is positive, so how do I move it? Subtract. So I subtract 12 from each side. So 7x is equal to negative 28. Divide by 7, divide by 7. X is equal to negative 4.
Oh.
Okay? Check and see, where did you make your mistakes?
7 and everything goes well. I said 28 divided by 7 is 7.
All right. Now, on page 38. Page 38, we are dealing with adding and subtracting our polynomials first. Then we are multiplying and dividing in the bottom half of the page. I want to do the adding and subtracting first. Okay, so we'll do left-hand column of adding and subtracting, middle, and right. Everybody with me? All right. I'm going to call out the answers to a column and then ask if we need to work any. So the first one, I have 6d squared plus 3d plus 7 plus d squared plus d plus 2, and your answer should be 7d squared plus 4d plus 9. Underneath that one, your answer is 7g squared minus 5g plus 3. Underneath that one, negative n squared plus n minus 5. And then the last one in that column, negative 2 squared plus x plus 2. Questions? Any of those you would like me to work? All right, the middle column of addition and subtraction. The first one is 5e squared plus 3e plus 7. Underneath that is 3h squared minus 3h plus 9. Then I have negative 3p squared minus p plus 3. And the last one is negative 2x squared plus 3x plus 2. Questions on the middle column. Last column, 6f squared plus 3f minus 3. Underneath that is 6i squared plus 3i minus 11. Then I have negative 3r squared minus 9r minus 1. And the last one is negative 3x minus 8x minus 2. Questions on any of the addition or subtraction of polynomials? Did you change to adding the opposite? Did you change your subtraction, or did you end up missing those? Okay. Now let's look at our multiplication and division. We're going to go down the left-hand column, middle, and then right. Okay, so left-hand column, when I multiply variables, what do I do with like variables? What do I do with their exponents? Add them. When I am dividing and I have like variables, what do I do with their exponents? Subtract them. Good. So left-hand column, I've got 7y to the 5th times 4y cubed, z to the 4th times 8y to the 5th, z cubed. And I end up with 224 y to the 13th, z to the 7th.
It's a big number.
Questions on that one? All right, underneath it, 3f to the 6th times negative 4f to the negative 3rd, g to the 8th, times 7f squared times g to the negative 5th. You should end up with negative 84f to the 5th, g cubed. What number do I mean when I say cubed?
3.
Yay.
Yay.
All right, now moving to division, I have 39a to the 5th divided by 13a squared, and you should end up with 3a to the 3rd. Questions? Underneath that, 32d to the 5th, e to the 8th divided by 4e to the 6th, you should end up with 8d to the 5th, e squared.
Oh, third is 2.
Mhm.
I got confused.
48j to the 9th, k to the 6th divided by 12j to the 7th, k squared. You should end up with 4j squared, k to the 4th. And then the last one, 27t squared u divided by 9t to the 4th u. You should end up with 3t to the negative 2nd power, or you could have 1 over t squared. I'm sorry, 3 over t squared. So 3t to the negative 2nd power.
Negative 2nd power?
Mm-hmm. So let's see, that's the very bottom one.
I forgot to negative.
Let's look at that one for a minute. Okay, so the first thing I'm going to do is 27 divided by 9 is 3. Then I have t squared minus 4, okay, because I have t to the 2nd power, t to the 4th. And then I have u to the 1st plus 1. Oh, I'm dividing, not adding. U to the 1st minus 1. Okay, so 3t, this is going to end up being 3t to the negative 2nd power. If I have 1 minus 1, what does that equal? 0. So u to the 0 power equals what?
Nothing.
1. So if I were to multiply 3t to the negative 2nd by 1, I still end up with 3t to the negative 2nd power. Okay? Now, in that, remember we talked about negative exponents? So that negative exponent is with t. So basically, this is 3 times 1 over t to the 2nd power if I made that negative exponent positive. Because remember, to make a negative exponent positive, I have to take the reciprocal.
But do
Okay.
we have to do that?
The only time you have to do that, listen up please, the only time you have to do that is if it says to express all answers in positive reciprocal form. I mean, so positive exponent form. So if my direction said my exponent has to be positive, but then if I were to multiply that, that's the same as 3 over 1 times 1 over t squared. So this is actually 3 over t squared, is to write that with a positive exponent. So if the directions say to leave it in positive exponential form, then you do have to take the reciprocal. So you need to know how to do that. All righty, so that was our left-hand column. Moving on to the middle column. Okay, at the top, Your first one should be 120 b to the 14th c to the 13th. Underneath that one, you would just have negative 45j. Underneath that one is 6b to the 5th.
Oh, I got.
Then I'm going to have 7f to the 4th g to the negative 5th. Then I have 8m to the 7th n. And then the last one is 5b squared w to the negative 3rd power. Questions on the middle column?
Can you do the second to last?
Second to the last, the 72m cubed n squared.
Yeah.
Okay, so let's take a look at this one. 72 divided by 9 is
Yeah.
8. Then I have m cubed minus a negative 4, n squared minus 1. Okay, so 8m, 3 minus a negative 4 is the same as 3 plus 4, so that makes 7, because remember, change from subtraction to addition and take the sign of the opposite sign. So 8m to the 7th, and then 2 minus 1 is 1, so I don't have to put an exclamation for m. Okay, look and see if you missed it. Why did you miss it? Last column. All right, the last column, 189d to the 9th, e to the 8th. 378k to the negative 3rd, m to the negative 1st. 7c to the 18th. 9hi. Then 25p to the negative 2nd, r to the 3rd, I think, or is it negative 3rd? Negative 3rd. Okay, I thought it. All right, and then the last one is 16x to the negative 2nd power y squared. Any questions in the left-hand and in the right-hand column? All righty. Okay, so let's go ahead and take a look at our lesson chart for a minute. Remember, this is not only good for keeping up with your homework, but it also tells you what lessons are combined for each unit test. So it helps you know when your test is coming, okay? So the last assignment in Unit 2 was Lesson 15, dividing monomials. Okay, so we have already completed everything for Unit 2. So what we're going to be doing today is we're going to be working through reviewing these different skills that we have used that will be on the test. Today is the time that as you're working, if you don't know how to do something, you ask me for help, okay? Because the test is coming up. It will be going home on Thursday. That means it'll be due to be uploaded the next Monday, all right? In grading homework, last night, I think I got another batch of homework sent out. And so what I want to make sure that we're doing before the test is that you are reviewing and asking questions, okay? Test grades on the last test weren't as high as I would like them to be. And I understand that we're in a different situation right now, but also, you know, I've emailed you back your test with corrections and what your final grade is. I think there may be 1 or 2 that had not uploaded some corrections or something. I'm not real sure. I'll have to look back and see. But anyway, so you should have gotten your test with corrections. I'm typically emailing you. If I have your email address, I'm emailing you and the parent back those things. If it's just going to your parent, then you need to make sure that y'all are communicating to get them. If you need to add your email, if you want me to email you directly and I'm not yet, please be sure to write down your email and give it to me so I can add you to the list. Because remember, it's the kind of thing where per the co-op, if you're not making at least a 70% by the time we get out for Christmas, then you can't come back in January. Okay, so if you don't have at least a 70% in the class, then in January, you can't come back to class. And I don't want to lose anybody because of grades, because I want you to ask help if you're not understanding something. Like I want to mention, the uploading the homework stuff. I know that from time to time you can check after you've uploaded something, click off the screen and then go back to it and make sure that you are looking at what has been uploaded for your assignments, okay? Because I know there's been several people that have uploaded stuff, but for some reason when I pull it up, it is not there, okay? Likewise, there are some forms, there's somebody, who is it? It's my geometry class. Also make sure it's either in PDF, I think in PDF form for the system. There's somebody that uploaded in some weird document and it won't open. So make sure you're uploading in a PDF form. If it's your app or your scanner app that you're having trouble with, you may need to find another one. Or if you just need to text or email pictures to me, that is fine, okay? I just need to make sure that we're getting your work. Sadie?
Did you say 75?
70. As long as you're a 70 or above, you're fine, okay? So you need to be checking your average, especially when I send out a packet of homework grades. You need to log in and see who you are, because I have a lot of parents that come to me and go, well, they told me they had an A. Well, have you been looking at the system, okay? Look at your grades. You should know what grades you have at all times in all of your classes, okay? Y'all are taking high school level classes, so you should be having high school level responsibility now by keeping up with your averages so you know where you are. That also helps you to know, hey, if I made an okay grade and I'm fine with it, maybe I don't want to do my test corrections, and that's up to you. But then you may say, hey, because of my grade, I better do test corrections. And one thing about test corrections, look back. If you missed it on the test, that means that there's something that you didn't understand. So look back at the lesson in the textbook. Look at your steps. Look at what to do to correct that, okay? That's your time for learning, is doing those test corrections. So obviously there's something not quite clicking, so we need to look back at the lesson, and you can look back at the book while you're doing your corrections, okay? So, so be sure to do that. I'm going to go ahead and pass out our review packet that we're going to go through today. Oh, I already gave you one.
No. No, only the back.
Do them backwards.
Yeah.
It's imaginary number. I finally got there.
Oh, no.
All right, put your name on it.
Yeah, I'm fine.
Go ahead and put your name on your paper. Now, it is a Monday, and in true Monday fashion, the copier was given bits, and somehow I managed to make copies where the back side is upside down. Okay, so on every single one, the back copy is upside down. Sorry about that. You'll just have to flip the paper over. Okay. Let me pull this up real quick.
It looks like my cat.
Well, I don't know what it looks like.
Well, I did okay.
Yes.
Why didn't you number them already?
Huh?
Why did you number them already?
So you wouldn't have to.
That's my two.
You can renumber them.
You fell over it.
Okay. Algebra 1, Unit 2. Hey, and it's a good thing I did with these papers being upside down and stuff. I would have never been able to put them.
Yeah, I got my packet set up, so I went and did some of it. Study hall, so she gave it to you earlier. Yes! That's how I already had it. Was it? It's okay, it just means I can help you. I'm like, that's stuff.
Oh, wait. Yeah, that's gross.
I just take a lot of notes. I don't.
All right.
I just take notes and do it.
There should be something on this first page that you were seeing that does not look like something we've done before. What is it?
It's a variable.
It's a variable under my radical, isn't it?
Yeah.
Okay.
That's scary.
So what I want you to do is at the bottom of your page, we're going to take a couple of notes on here. Okay? So when we're simplifying radicals, what is the first thing that we need to do?
Prime factorization.
We need to do prime factorization. We need to list the radicand as factors of prime numbers. So step 1, list radicand as product of prime factors. Okay, so the first thing we need to do is list the radicand as the product of prime factors. What do I do after that? How do we make them go outside?
Buddy.
How do we determine how many buddies we need?
Is X index.
Index. Good. So step 2 is going to be to use the index to determine the number of buddies. I'm going to put buddies in quotes because this is not a mathematical term.
I said buddy slash use the index.
Okay, use the index to determine the number of buddies. So what is it? What do we do when our buddies, when we have everything buddied? What's our next step?
Add and subtract. No, multiply the number. No.
What? After the buddy, you bring them out. You
All
bring 'em out.
right. Praise the Lord, my son was negative for COVID.
Woo! You got strep?
Negative for strep, negative for COVID. He does have an ear infection.
Oh, rip.
So I was sweating that. He got up this morning and was talking about a sore throat. Our whole family already went for COVID test last Monday. We all got to go.
The nose thing?
Yes, and it was awful. So I knew he felt bad today because he like freaked out. He's bigger than me, okay? He's like 170 pounds, 5'8" or so. He's 12 years old, okay? But he's bigger than me. So he hates shots. He hates all that stuff, and so he freaked out about the COVID test. It was funny because after he saw me do it, he got up and he was heading out the door at the doctor's office. He's like, I'm out. I'm not doing this.
Okay, so
And I was like, yes, you are. Go sit down. He's like, I'm not doing this. And I was like, yes, you are. So my husband and I had to sit there and hold his hand and coax him through it. So this morning or last night he was saying he felt bad. So this morning when he said his throat was hurting and I said, your first class is PE. Let's give you some medicine. Stay home for a little while. Daddy will go check you in and you'll go for your other classes. And so when it was time for them to go, he was like, my throat really hurts. I was like, you do understand that if you're saying your throat hurts and you don't feel good, you were just with your grandparents this weekend and you did a sleepover. So you're going and you're getting a COVID test and a strep test. So when he agreed to that, I knew he felt bad. When he said, okay, I'll go.
Lock him out.
Anyway, so I've been sweating it going, what am
I can tell the story.
Because that means I'd have to go home.
My uncle works in security and every week he has to get tested. Because it's at a hospital.
That's fine. So,
She had COVID when it first came out, so she didn't get it.
I don't think I had it in January, and so I was asymptomatic when I had well, you can get immunity, but you can always get it again sometimes.
Oh, yes. I have a friend that has queso.
okay.
It's really annoying.
Okay, so And then I'll just say,
Oh my goodness. So many
alrighty, let's get back together real quick. Bring it back together. All right, sorry to digress, but I was just very glad because I didn't know what I was going to do. If I ended up having to go home, but y'all are here, I didn't know how I was going to teach and do all this stuff. All right, so step one, prime factorization of our radican. Step two, use the index to determine our buddies. Okay. Step three, our buddied groups. And again, I'm going to put that in quotes because it's not a real term. Buddied groups come out as one whole number. And I'm going to put in parentheses, if more than one multiply together. And then our unbuddied numbers. Again, that's a Jennifer term. Unbuddied, we'll call them values, stay under the radican. And I'm going to put in parentheses, if more than one multiply. Okay, so step one, prime factorization of your radicans. Step two, use your buddies and use the index to determine buddies. Step three, whatever we found as buddied groups come out as whole numbers. If there's more than one, you multiply them. Whatever's left unbuddied stays under the radican, and if there's more than one, you multiply those back together. So we do exactly the same thing when we have variables in our radican. Okay, so we're going to list them out as prime factors. So let's start with the prime factorization of 125. Remember, when we are doing prime factorization, I find it easier to go ahead and start it with the smallest prime factor. So I'm always going to start with the number 2. 125 is not even, so I know that it's not divisible by 2. So then I look at it and try to determine, is it divisible by 3? My divisibility rules tell me that I can add 1 plus 2 plus 3, 1 plus 2 plus 5 to determine if the total or if the sum is divisible by 3. 1 plus 2 plus 5 equals 8. That is not divisible by 3, so I know 3 is not going to work. What is my next prime factor after 3? 5. 4 is not prime. 4 is 2 times 2, so I'm going to try 5. And 125 is divisible by 5 because it ends with a 5. So our first prime factor will be 5. 5 times what is 125?
5.
15.
25. It's 15, right?
15.
What is it?
15. A number?
There's calculator. Or divide. If 5 will go into 12 2 times, we know that the number's going to start with a 1. Okay?
25.
I'm sorry, 2 times is going to start with a 2.
I know, but I was
All right. So we know it's 5 times 25. Now we have to break 25 into prime factors. What is that?
25.
No, we're breaking 25 into prime factors. What makes up 25, Sadie? 5 times 5. Good. So we have 5 times 5 times 5 equals 125. So we've expressed that as prime factors. Now n, I only have one n. So I'm going to list it as one of my prime factors is n. What is step 2?
Buddies.
Use my index to determine buddies. How many buddies do I need?
2.
2 buddies. I have 2 5s. So that means those 2 5s can come out as one whole group. What is going to be left under the radicand? 5 in. Because I didn't have a buddy to go with in, it has to stay under there. All right, let's look at number 3. 512k squared. Ooh, what's my smallest prime factor of 512? 2. We know that because it's even. What is 512 divided by 2? 256. What is my smallest prime factor? 256. 2. How many times will 2 go into 256? I don't have people paying attention. Okay. So now we've got to break down 256. What did you say? 128. So smallest prime factor of 128 is 2. What is 128 divided by 2? 64. 64 divided by 2 is going to be what? 32. 32 divided by 2 is going to be what? 16. 16 divided by 2 is 8. 8 divided by 2 is? And 4 divided by 2 is?
Wait, so how many 2s is that?
Let's look at it and see.
It's 9 2s.
All right, so listen up, please. Let's check and see if we have the right amount of 2s. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. 32 times 2 is 64. 64 times 2 is 128. 128 times 2 is 2 whatever, and 2 whatever times 2 is going to be 512. Okay?
256.
Okay.
No one to go to the mall.
All right. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9 2s. So we know we're going to have 1 that's left behind. What am I going to do with those K's?
Shove them together.
I'm going to have K times K. Because it's K squared. Listen up. Because this is K squared,
Yeah.
I break it apart as K times K. Remember, my exponent of 2 tells me I have 2 K's. All right, because K times K is K squared. What is K plus K? 2. 2 what? 2K. If I add K plus K, that's 2K. But if I multiply K by K, that's going to be K squared. All right, so we've done step 1. We've listed our prime factors. Step 2, look at the index, determine our buddies. So there's a group there and a group there and a group there and a group there. And I can buddy up my K's. I have 2 K's. So how many groups of 2s do I have?
4.
I have 4 groups of 2. So I've got 2 times 2 times 2 times 2 times K that comes out. What is left under the radicand?
2.
A 2. So my answer, what do I do with all those 2s that came out? Multiply them. What's 2 times 2 times 2 times 2? 16. So I have 16K times the square root of 2 is my final answer. Any questions on how we did that? Okay, let's go ahead and look at number 5. I have 216, K to the 4th. What is my smallest prime factor? 2. 2 will go into 216. How many times?
108.
108. 108 divided by 2 is what?
54.
Close. Yeah. Yeah. 54 divided by 2 is 27. 27. What is my smallest prime factor? 27. 3. 3 times what is 27? 3 times 9. So that's going to be 3 times 3. And then let's list out our K's. 1, 2, 3, 4 K's. Take a break. Thank you for your help. All right, watch yourself. stuff, I'll come here and you can come this way. That way we can sort of get through.
Is your son okay?
Yeah.
You gonna give him antibiotics for the ear infection? That'll be fun. I did.
Hey, Brooke, this is Jennifer Fountain calling. I needed to see about changing my appointment in my class schedule for tomorrow. That's not for sure. You know, it's not like we don't be here in this week.
You just like doing the default dance in my face.
I was gonna see if I could have a
Give me some. I throw it in the trash.
whatever that last week is.
Give him back.
All right. So we just wrote down this into prime factorization. The more we get done in class, the less homework you have. Okay? Does everybody hear that? The more we get done in class, the less homework you have at home. So we want to make sure that we're getting it done. Okay, so we listed our prime factors. Let's go ahead and group our buddies. I have a group of 2s, I have a group of 3s, and I have 2 groups of Ks. So I pull out my group of 2s, I pull out a 3, and I'm going to pull out 2 Ks. And then what's left under the radical?
2, 6.
2 and 3. So now I'm going to multiply everything together. 2 times 3, I'm going to have 6K squared on the outside. And underneath my radical is going to be 2 times 3, which is 6. All righty. Now we're going to go ahead, and since we've gone through simplifying radicals, we're going to move to the next page, which I'm sorry that yours is upside down. So turn your page and flip it around. All right, so this page we are adding and subtracting radicals. Okay, so we've talked about this where we know that with our radical, what has to be the same to be able to add or subtract?
The radicand.
The radicand and the index. So at the bottom, I want you to go ahead and make a note. Index and radicand must be equal to add or subtract. So let's go ahead and look at number 1. I have 3 times the square root of 6 minus 4 times the square root of 6. The first thing I'm going to do is I'm going to subtract, and I've got 3 minus 4 equals what?
-1.
A -1. Then I keep my radical the same. So -1 times the square root of 6, I can simplify that and just write it as the negative square root of 6. I don't have to write the 1. I can write it. It's up to you. Now this is where we have to be super careful about adding and subtracting positives and negatives. Let's look at number 3. I have -11 minus 11. So when I have -11 minus 11, I want to change my subtraction to adding the opposite. So that means I have -11 plus a -11. Now I can see that I know that I've got a negative plus a negative. So I know when my signs are the same, I keep my sign and I add my numbers together. So that means I'm going to have -22 times the square root of 21. Now, what I need to make sure of is when I leave something under the radicand, so like the first one I had 6, I know that when I break that into prime factorization, that's 2 times 3, I know it's 26, I know that 6 cannot simplify. 21 is going to be 3 times 7. Again, prime factorization, I've got 2 different prime numbers I couldn't buddy and simplify. So I always want to check and make sure if I could simplify, if I can, but there's nothing I can do there. Look at number 5. I have -10 plus 12. Opposite signs, I keep the sign of the larger and find the difference of the numbers. So what is -10 plus 12? Positive 2. Good. So 2 times the square root of 7. Let's look at number 7. -10 minus 11. -10 minus 11. I'm going to change that to adding the opposite. So that means I have negative 10 plus negative 11. What is negative 10 plus a negative 11?
Negative 21.
Negative 21 times the square root of 11. All right. Look at number 9. What are my rules about adding and subtracting radicals?
Add the opposite.
Index and radicand have to be the same. At first glance, these are not the same, are they? What can I do?
You can multiply.
The square root of 6 is in simplest form, right? I know that's 2 times 3. Is the square root of 27 simplified?
No,
simplified.
simplified.
You can multiply 6 and 24 and so they'll both 6.
Okay, so let's take a look at that. I know that 2 times the square root of 6 is in simplest form. But when I look at the square root of 24, what are my prime factors of 24? Smallest prime factor?
2.
2 times what?
12.
12. Smallest prime factor of 12?
2.
2 times what? 6. Smallest prime factor of 6? 2 times 3. So now look, I've got 2 times the square root of 6 minus 2. I have a group of 2's in that, under that radical that can come out. So that means I'm going to multiply that to the first 2 that was already there. And underneath my radical, I have 2 times 3. Now, I've got 2 times 6 is still my first term, minus. I multiply these 2's together. This was the 2 that I started out with, and the 2 that I pulled out from underneath the radical. And so 2 times 2 is 4. And what is 2 times 3 under my radical? My radicand is now 6. Now my radicands are the same. So now I have 2 times the square root of 6 minus 4 times the square root of 6. So what is 2 minus 4?
Negative 2.
Negative 2 times the square root of 6. Okay, so sometimes you can simplify to be able to add or subtract.
Did you multiply to?
You can multiply and they don't have to be the same. Okay, I don't have to do prime factorization to multiply at first. To simplify, then I have to be able to. Okay, we'll look at that in a minute, I think. I don't remember if I have. So let's look at number 11. Which of these could be simplified more?
Well,
The negative square root of 12. So I'm going to leave that negative there. What does that imply is in front of that radical?
-1.
Negative 1. So if it helps you to go ahead and write that as negative 1, go ahead and write that as negative 1 times the square root. What is my smallest prime factor of 12?
2.
2 times what is 12?
2.
Okay, so we're going to do 2 times 2 times 3, good, plus 3 times the square root of 3. What can buddy up?
2.
My 2's. So that means a group of 2 comes out. It's going to be multiplied by that negative 1. I have a square root of 3 that's left over. So now negative 1 times 2 is going to be negative 2 times the square root of 3 plus 3 times the square root of 3, which is going to equal what?
3.
Negative 2 plus 3 is going to be a positive 1 times the square root of 3, so I can just leave that as the square root of 3. Okay, go ahead and let's flip the page for a minute. Variable and verbal expressions. So in here, we have our statements that we have to change to write an algebraic expression. So the first one, the difference of 10 and 5. How am I going to write that as a math problem?
10 minus 5.
10 minus 5, good. Look at number 3, u decreased by 17. What is that going to be?
-17.
U minus 17. Number 5, x increased by 6.
Times.
X plus 6. Increased by is going to be addition. If it says increased by a factor of, then I know it's going to be multiplication. The sum of q and 8.
Q plus 8.
Equals 8. Good, q plus 8.
I think it means times.
Okay, so we said that would be q plus 8. What is twice q?
2 to the second.
Think about if I
Or
say,
addition.
when we talk about twice, I'm going to multiply by 2.
Okay.
Okay, so twice q would be 2q. The quotient of 18 and n.
14 divided. Wait, that's 7.
Number 11, how would I write
Oh,
that as a
wait.
problem?
We're down here.
The quotient of 18 and n.
18 divided by n.
18 divided by n. Let's look at number 13. Now we're writing the verbal expression of the algebraic expression. So when I have a fraction, what operation do I tell you that that implies? Division. So how would I write this?
X divided by 2.
X divided by 2. How would I write number 15? How would I write number 15? 19.
Difference of 19
You could say the difference of 19 and 3. You could say 19 minus 3. You could say 19 reduced by 3. There's all kinds of different ways that you could say that. Okay? You can choose how you want to say that. You could not say 19 less than 3 because that implies that you're subtracting 19 from 3. But you could write 19 less 3. Okay? So any of those would be acceptable. Let's move on. Whoa, where'd my paper go? To using the distributive property. Remember that when we distribute, we want to make sure that the term outside of parentheses gets multiplied by each term inside parentheses. So in the first one, I have -6 times a plus 8. So that means I'm going to multiply -6 times a, which is -6a. Then I have -6 times a positive 8. A negative times a positive is a negative. 6 times 8 is 48. Remember, this is where we have to think about our rules about addition and about multiplication of signs.
Do we have to solve it?
No, because we don't have that it's equal to anything. So the only time I can solve is when I have a complete equation, when it tells me what is equal to. So that's in simplest form. Number 3, I'm going to distribute 6 to -5n and distribute 6 to 7. 6 times -5n is going to be what? -30n, and 6 times 7 is 42. So plus 42, because it's positive, that's how I have a plus sign in the middle. Look at number 5. I can distribute going this way too. Okay, so I have -8 times -4. Negative times a negative is a positive, and 8 times 4 is 32. Now I have a -8 times a -3n. A negative times a negative is a positive, so now I'm going to have plus, and what's 8 times 3? 24n. Number 7. I'm going to distribute backwards. And so 5 times 1 is 5. -7n times 5 becomes -35n. Number 9. 5 times 3m, 15m, and 5 times -6, -30, so it will be -30. Number 11. 5 times b minus 1. 5 times b, 5b. 5 times -1. -5, so it will be -5. So for that second term, whether we have a plus or a minus depends on if we're dealing with a negative number or a positive number. That's how you determine what your sign is between the two terms. Okay? Any questions on distributive property? All right. Evaluating using the given values. So in this section, I have to make sure that I plug in the number that they have told me to use. All right. One of the things that I like to do, because let's see. All right, they were nice on this one. Well, yeah. They were nice because they didn't give us any negatives. Okay? They did not plug in, they didn't give us any negatives to plug in. So let's go ahead and look at the first one. Y divided by 2 plus x. So we're going to use x is equal to 1 and y equals 2. So I'm going to rewrite my equation or my expression, and I'm going to have 2 divided by 2 plus 1 equal. Order of operations tells me I'm going to do what first? Divide, then add. 2 divided by 2 is 1, and 1 plus 1 is 2. Let's go ahead and look at number 3. 1 and p equals 5. So I have p squared plus m. So I'm going to have 5 squared plus 1. What is 5 squared?
25.
25 plus 1 equals 26. Good. Number 5. I want you to go ahead and work that one on your own. M is 1, P is 5. So I have 1 plus 5 divided by 5. What do you have to do first? Divide. What is 5 divided by 5? Nope. 1. So I have 1 plus 1 equals 2. I want you to work number 7. Working number 7. Did you get 84? Okay, you could have done 2 different things here. You could have either distributed like I did, because I said, hey, if I add 6 and 8 and that's 14, then I have to multiply 14 times 6. I don't know what that is off the top of my head. But I do know that 6 times 6 is 36, and I do know that 6 times 8 is 48. So if I add 36 plus 48, I get 84. Okay? I'm looking for the path that's going to be the easiest to do. Go ahead and work number 9. And with 3 cubed plus 10 plus 9. What is 3 cubed?
27.
27. Good. I saw on several things I was grading this weekend where people would have 3 to the 3rd power was 9. Do not multiply your base and your exponent. You multiply your base by the number of times as the exponent tells. So 3 to the 3rd is 27 plus 10 plus 9. So 27 plus 10 is 37. And 37 plus 9 is 46. Do number 11. Think about your order of operations here on number 11. According to the order of operations, what am I going to have to do first? Exponents. What is 7 squared? 49. If I have p squared m, what does that mean I'm going to do 49 and my value of 4 for M?
Multiply.
Multiply. What is 49? I've got 49 times 4 divided by 4. Order of operations tells me I'm going to do what? I'm going to multiply, then divide. Remember, if I have multiplication and division in the same problem, I work it from left to right. Going left to right, the first thing I have is 49 times 4. What is 49 times 4?
196.
196. Now, 196 divided by 4 is going to give me what?
49.
49.
There's really no point to that.
Okay.
I think I'm gonna skip the problem and still got it right.
So 49 is your answer there. Do number 13.
Already did that one.
Awesome. You should have 7 minus, and then parentheses, 3 divided by 3 minus 1. What am I going to need to do first? Parentheses, and inside parentheses, what do I do? Divide. 3 divided by 3 is 1, and 1 minus 1 is what?
0.
0. So I have 7 minus 0 equals
7.
7. Good job. All right, turn to the next page. 7. All right. One of the things I do want to mention is, listen up, please. One of the things I want to mention is as you're going through your homework, when I send homework scans back with your grades or whenever we're doing problems in class, it's very important that you identify what your mistake was and why you made it. Was it a careless calculation? Was it a problem adding or subtracting and you did that incorrectly? Did you do the steps out of order? Was that where the problem came in? But by looking at what you missed and understand why you missed it will help you to do better the next time, okay? So that's part of learning, is identify what did you miss, why did you miss it, so you know next time you do it, you can make sure not to mess up again, okay? Let's look at combining like terms. Remember like terms? When we talk about a constant, what is a constant?
The one in front of the variable?
Huh?
The one in front of the variable?
No, not the one in front of the variable. That's a coefficient.
It goes, oh, it's like a
Huh? It's just a number. A constant is a number by itself. So look at number 3. What are my constants in number 3?
10 and 3.
10 and 3 are my constants. Okay? The coefficient is a number that comes before the variable. So in number 3, my coefficient is 9. And my variable is n. Okay? So when I'm combining like terms, I'm looking at combining coefficients of like variables, okay? Or I'm looking at combining constants. So let's go ahead and look at the first one, negative 6k plus 7k. These are like terms because they both coefficient and the variable k. So all I do is I say negative 6 plus 7 is what? 1. So I've got 1k, and that would just simplify to k. Look at number 3. What is n plus 9n?
10n.
10n. What is negative 10 minus 3?
Negative 13.
Negative 13. Good. Negative 10 minus 3 is the same as negative 10 plus a negative 3. Okay? If you need to change it to adding the opposite, go ahead and do that so you don't make that mistake. Look at number 5. Negative r minus 10r. That's the same as saying negative 1 minus a negative 10. So that means no, let's take a look at it. Change from addition to subtraction and subtract the opposite. Add the opposite. So this started out as a negative 10. When I change this to addition, I have to take the opposite of negative 10 and it becomes positive 10. Because in front of r, remember my understood coefficient, if there's no number written there, I understand it to be a 1, and there's a negative in front of it, so it's negative 1. So if there's no coefficient, you make sure you put in 1. So now I have -1 plus a +10 is going to be what? -1 plus a +10 is a +9, so my answer is 9R. Look at number 6, number 7. 11R minus 12R. -1R, and we can simplify that just to -R. Number 9, -8x minus 11x. That's the same as having -8 minus 11. So I'm going to change that to -8. I want to add the opposite. I change my subtraction sign to an addition sign. 11 is positive. Once I'm using this as my sign here. That's why I put this in parentheses so you can see it. Because I'm using my subtraction sign here, now we can see that 11 is positive. Okay, so that's why I put it in parentheses. So the opposite of positive 11 will be -11. So now I have -8 plus a -11. What is -8 plus a -11? -19. Number 11, 5n plus 11n? 16n. Number 13, I have 12r plus 5 plus 3r minus 5. What is 12r plus 3r? 15r. And what is 5 minus 5? 0. So for 13, your answer is just going to be 15r. All right, turn to the last page. Simplifying each expression, and this I've recently been working on with adding and subtracting polynomials.
This is the last.
It should be the last. Hold on a second. Hold on.
No, there's a page 7.
There.
It's just upside down.
It should be page 7.
Oh, there it is.
Page 7. Yeah, it should be right side up.
Yeah, it's just confusing.
And then this is the not correct.
Okay, so listen up. This is where I want to make sure when I'm adding and subtracting polynomials, it is going to help to rewrite them vertically. Okay, so let's look at the first one. I'm going to take 5p squared minus 3 plus 2p squared. Oh, hold on. Remember, we got to put these, hold on. Actually, on these, we don't have to worry about writing them vertically with the 2, when we're just doing 2. But when you're doing a trinomial, we do want to go ahead and put those, line them up. So let's look at number 1. What is 5p squared plus 2p squared?
7p to the 4th.
Good. You have to add your exponents, because remember, p squared times p squared will be p to the 4th. So, no, I'm sorry, that's multiplying. We keep our variables the same when we're just adding. So 5p squared plus 2p squared is going to be 7p squared. Do I have anything that I can combine the -3 with? No. Do I have anything that I can combine the -3p to the 3rd power or -3p cubed?
No.
Nope. Look at number 3. I have 4 plus 2n cubed plus 5n cubed plus 2. 2n cubed plus 5n cubed is going to be what?
7n cubed.
7n cubed. And 4 plus 2 is 6. Look at number 5. 3a squared plus 1 minus 4 plus 2a squared. When I'm doing this, remember, it's going to be easier if I go ahead and add. So what I want to do is underneath it, I'm going to write 3a squared plus 1. I'm going to change from subtraction to addition, but now I need to take the opposite of everything else in parentheses afterward. So 4 becomes -4, and plus 2a squared becomes minus 2a squared. because I changed from subtraction to addition, I have to take the opposite of every term in parentheses, okay? So 4 was positive, it becomes negative. 2a squared was positive, so it becomes negative. So now I have 3a squared minus 2a squared. What is that going to be?
A squared.
A squared. If I have 3a squared minus 2a squared, that's going to give me a squared. And then I have a positive 1 plus a negative 4. Positive 1 plus a negative 4. What kind of 3? Negative 3. So a squared minus 3. Look at number 7. I'm going to keep 5a plus 4. I'm going to change from subtraction to addition, but that means I have to change the signs of everything inside parentheses. So 5a becomes negative 5a, positive 3 becomes negative 3. Work out. Did you get one?
Yeah.
Okay, 5a plus a negative 5a is 0. Okay, and then 4 plus a negative 3. So 5a plus a negative 5a. 5a plus negative 5a is 0. 4 plus negative 3 is 1. Now, on number 9, I do want to line these up vertically, but I have to make sure that when I line these up, everything lines up in the correct placement, okay? So if I start with negative 4k to the 4th, and I am adding, actually, we'll go ahead and just write the first one, negative 4k to the 4th plus 14 plus 3k squared. Now I'm going to add. What needs to go underneath negative 4k to the 4th? Negative 3k to the 4th. What needs to go under 14? Negative 8. What needs to go under 3k squared? Negative 14k squared. Do you see how we made sure to line these up based on the variables and the exponents? I need to make sure that they are lined up with the same variable and the same exponent. So now I have negative 4k to the 4th plus a negative 3k to the 4th. What's negative 4 plus negative 3? Negative 7k to the 4th. Now I have 14 plus a negative 8. Positive or negative? Positive 6. One of the things I want to mention is make sure you are putting signs in between your numbers. I saw some homework that I haven't graded yet from adding and subtracting polynomials. You must have your signs in between. The way you know what sign goes there is based on is it a positive or negative number. So look, our last one is 3k squared plus a negative 14k squared. Okay, so positive 3 plus a negative 14 is negative 11k squared. Now what I want to do is I want to go ahead and put this in the proper order that it needs to be written in. The way that I know the order that this can be written in is remember we talked about alphabetical order. Well, we're only dealing with k's here. But I go in order from highest exponent to lowest, and then I always want my constants to be last. So my highest exponent is going to be negative 7k to the 4th. So I'm going to write that one first. Then I have negative 11k squared, and then the last would be plus 6. So that's putting that in order. That's the proper order you would write that answer in. You're going to put your exponents for, I mean, your variables with exponents first. Start with your highest exponent of 4. Then you use your next exponent of 2, and then constants come last. All right, we're going to rewrite number 11 in vertical format, but I also want to change from subtraction to addition. So that means that when I do that, let's take a look at what that's going to look like here. My minus sign is going to become a plus. 10a, is it positive or negative? Jonas, positive or negative? 10a, is it positive or negative? It's positive, so it needs to become what? Negative. Negative 2a to the 5th needs to become what? Positive 2a to the 5th, and negative 14a to the 4th needs to become positive 14a to the 4th. So go ahead and change them before you line them up vertically. So now we're going to keep the first one exactly as it is, 12a to the 5th minus 6a minus 10a cubed. And then we're going to put plus negative, where does our negative 10a need to go? Unsay, negative 10a. Where does negative 2a to the, I'm sorry, positive 2a to the 5th go? Under 12a to the 5th, so that's going to be positive 2a to the 5th. Where does 14a to the 4th need to go?
Right. I can't go.
Doesn't have a place to go, does it? So what I need to do is I can fill in with a placeholder 0 under the a cubed term, and I can go ahead and put plus 14a to the 4th. If it doesn't have a place, then I just need to put a placeholder 0. So I have 12a to the 5th plus 2a to the 5th is going to be what? 14a to the 5th. Negative 6a plus negative 10a, negative 16a. 10a cubed plus 0, negative 10a cubed, and 0 plus 14a to the 4th. So it's going to be plus 14a to the 4th. Let's go ahead and put these in order. I need to start with my highest exponent. What's that going to be? 14a to the 5th. What needs to come next? Plus 14a to the 4th. Then what would come after that? Minus 10a cubed. And after that, excuse me, negative 16a. So that would be our final answer. So if it involves subtraction, change to adding the opposite. When I check the opposite of every term in parentheses, I've got to make sure that I'm changing every term, okay? Now, realistically, you could, when you're writing these problems out, you could go ahead and put them in order first and then add or subtract, or you can add or subtract and then put them in order, okay? All right, so let's talk about homework for a moment. All right, so flip back to page 1. Page 1. Homework will be numbers 8 through 14. Page 1, homework, page 8, number 8 through 14. This will be one of those things that I will allow you to do the rest of the evens for bonus. Okay? So homework is 8 through 14, so bonus, and that's 8 through 14 evens, I'm sorry. So bonus will be 2 through 6 evens. Homework 8 through 14 evens. So circle numbers 8, 10, 12, 14. That is homework. 8, 10, 12, and 14. 2, 4, and 6 are bonus. So these are bonus. These are homework. Okay. Go to the next page. Adding and subtracting radical expressions. Numbers 2, 4, and 6 are homework. Evens, 2, 4, and 6 are homework. 8, 10, and 12 are bonus. 2, 4, 6 are homework. 8, 10, and 12 are bonus. Look at the next page. Let's do 2 through 12 evens are homework. 14 and 16 are bonus. Next page, distributive property. 2, 4, 6, and 8 are homework. 10 and 12 are bonus. 2, 4, 6, and 8 are homework. 10 and 12 are bonus. Distributive property.
Wait, say that again.
2, 4, 6, and 8 are homework. And then numbers 10 and 12 are bonus. Evaluating expressions. 2, 4, 6, 8 homework. 10, 12, 14 are bonus. Combining like terms. 2, 4, 6, 8 are homework. 10, 12, 14 are bonus. So that was 2, 4, 6, 8 are homework. 10, 12, and 14 are bonus. And then the last page. 6, 8, 10, and 12 are homework. Numbers 6, 8, 10, and 12 are homework. Um, 2, 4, 14, and 16 are bonus. So again, for every 4 will be a point of extra credit bonus that will be added to a test grade. Okay? So
What about 13 and 15?
13 and 15, if you want to do those for bonus as well, you can do those for bonus. Okay, so this, listen up about your due dates. This is due with your test. That will not be until next Monday. Okay? This is due with your test, which is next Monday. On Thursday, I will give you your test, and then it will be due when we're back on Zoom next week. Now, notice that this is a bunch of pages to upload. If you would rather take pictures and text it to me, feel free to do that. Or if you'd rather send it in an email, whatever's going to be easier. Okay? The only thing that I think that I did not have a review for was our absolute values. So listen up, please, as you're packing up. I want you to listen for a minute. There's the absolute value. Well, the absolute value wasn't on this, was it? That was last test. Oh, good. Okay. Alrighty, so that is going to be it for the test. All the things that you have on here are going to be what you need to be practicing on. What's in the packet is what's on your test. If you have questions while you're working through it, if you need help with anything before the test, please let me know.